Every single time you move your mouse, or you tap open an app, or you watch a video, there's this invisible director inside your machine, just orchestrating this incredible symphony of operations. And today we're going to pull back that curtain and meet the director, the operating system.
So let's just start with the central puzzle, right? Think about what you're doing right now. You've probably got a browser open, a dozen tabs, maybe some music playing, your emails syncing up. But get this, your computer's processor, at its core, can really only do one single thing at a time. So how in the world is all of that happening at once?
Well, the answer is, it's not. It's actually a brilliant, high-speed illusion. It's a magic trick, and the magician is the one piece of software you probably never think about, but you use every second of every day, your operating system, or OS. It's the mastermind that makes a single-minded machine look like a multitasking genius. All right, so let's get into it. Let's pull back that curtain and really explore this great illusion to see exactly how your OS pulls off this incredible trick. First things first, what is an operating system? Honestly, the best way to think about it is as the ultimate middle manager. It's this special set of programs that stands right between you and all the complicated hardware, the chips, the memory, the storage. It translates your simple clicks into complex instructions that the hardware can actually understand. It makes everything just work.
Now, the OS has a ton of jobs, but there are two that are just absolutely critical. It has to perform this constant, high-stakes juggling act with every single task you're running and every little byte of memory your computer has.
And in the world of the OS, a running program isn't just a program. No, it's called a process. That music player you have on? That's a process. That one tab in your browser? Yep, that's a process too. Every single one is a separate unit of work that the OS has to track, schedule, and give resources to. And each one of these processes goes through this little life cycle. It starts out as ready, basically just waiting in line for its turn on the processor. Then, for a split second, it's running, getting the processor's full attention. After that, it might go into a waiting state. Maybe it's paused because it needs you to, type something on the keyboard. And finally, when you close the app, it's stopped, and the OS cleans everything up. So how does it juggle all of this? The secret sauce is something called pseudo-parallelism. See, your OS is an unbelievably fast switcher. It gives a tiny slice of processing time to your browser, then bam, instantly switches to your music app, then your email, then back to the browser, doing this thousands, maybe even millions of times every single second. It happens so fast that to our slow human brains, it looks like it's all happening at the same time. It's not true parallelism, but it's a very, very convincing illusion.
Now, it wasn't always this slick. Early computers, they used something called monoprogramming. One program would load into memory, run its course, and only then could the next one start. This was, as you can imagine, incredibly inefficient. If that one program was just waiting for some data, the entire, super expensive machine would just sit there, doing nothing. Today we use multiprogramming, where dozens of processes share memory at once, which makes sure the processor is always busy and no resources are ever wasted.
And that brings us to the second part of this big juggling act, managing memory. The OS is like a really meticulous librarian for your computer's RAM. It knows exactly which shelves are empty, it assigns shelf space to new programs, and it cleans up and reclaims the space when they're done. But maybe the most important job it has is putting up these invisible walls between each program. It makes sure no process can mess with another process's data. This protection is what keeps one buggy app from crashing your entire computer. It's vital.
This whole elegant system, it didn't just appear out of nowhere. Its evolution is actually a pretty cool story, and it takes us from these massive, room-sized machines that you fed with paper cards all the way to the supercomputers that we all carry around in our pockets today.
I mean, think about it. Back in the 50s, it was one user, one task at a time. The 60s brought in something called batch processing, which was a little better. You'd group similar jobs to run one after another. But the real game changer was in the 70s with time-sharing systems. That's the idea that gave birth to the modern multitasking we were just talking about. And that idea, well, it led to today, where operating systems are just everywhere. On servers, our phones, our watches, even in our cars.
So we know the OS manages everything. But where does all of this incredible power actually come from? Where does it live? Well, to understand that, we need to look deep inside, at the very heart of the operating system.
Right at the absolute center of every modern OS is something called the kernel. You can think of it as the inner sanctum, a highly protected core that handles all of the most critical, fundamental jobs, talking directly to the hardware, managing memory, scheduling all those processes we talked about. It really is the boss of all the bosses.
So if your app is just a regular process, how does it get the all-powerful kernel to do something for it? Like, say, save a file to your hard drive. It can't just order the kernel around. That would be a total security nightmare. Instead, it has to make a formal, very polite request called a system call. It's the only official way for an app to ask for a privileged service from the boss.
And this whole process is so important for security. When your word processor wants to save a file, it makes that system call. The OS then does something critical. It switches the processor from the limited user mode that your app runs in to the all-powerful protected kernel mode. Only then does the kernel safely perform the action. Once it's done, it switches right back to user mode and hands the result back to the app. This little dance ensures that a regular application can't just go rogue and mess with the core of your computer.
Okay, so let's try and bring this all together. When you step back and look at the big picture, the operating system is the true unsung hero of computing. It's the invisible brain that makes our entire, complex digital lives even possible.
Probably the best way to think about it is to imagine your computer is this huge theater production. The OS? It's the director. It manages all the apps, those are the actors, telling them exactly when it's their turn to get on the processor. It allocates all the memory, that's the stage they perform on. It organizes all of your files, those are the props. It controls your keyboard, your mouse, your monitor, all the special effects. And through it all, it's making sure everything is secure and performing well, so that the whole show runs smoothly, without a single hitch.
At the end of the day, the operating system is what brings order to the absolute chaos of computing. It's been solving these huge problems of resource management for over 70 years now. But our world is getting so much more connected, right? With AI, the Internet of Things, virtual reality, the challenges for the OS are only getting bigger and more complex. So the question I want to leave you with is this: what's the next great illusion it's going to have to create for us?